Hello everyone. In this video I would like to show stepper motor programming using Haiwell PLC. We are going to use two PLCs, AC series and T series. AC series PLC is going to have push buttons connected to it. T series is equipped with frequency outputs, which will control our stepper motor. Motor will be started by pressing push buttons in PLC 1. States of push buttons will be exchanged between PLCs via Ethernet using Haiwell bus protocol. In first PLC in A series there is no actual need to do any programming. We just know that our push buttons are connected to X1 and X0 and X1. So X0 will be start forward command and X1 will be start backwards command. So we'll start programming PLC 2. So select our CPU type T16S0T. We call it PLC2 program and create main program. Okay. First we'll declare some components. So we will read X1 and X0 from PLC1 and we will store them in M0 tag. We will call it run forward from PLC1, run backwards from PLC1, and our actual commands: run forward and run backwards. Okay. Then we jump back to our main program and we'll start programming. First of all, we must read the data from PLC1. So we go to communication instructions, TCP, Haiwell bus read. Of course, we must declare our Haiwell bus read table. Read from PLC1. So we are going to read X0 and save it into M0 in our PLC, and also X1 save into M1. Okay, so we read from 111 IP address and we will declare our table. Okay. In next network we will make a condition to read commands from PLC1 and save them into our internal tags. So whenever we read M0, and maybe we'll do a raising edge, we will set our run command, which was M2. Yes, run forward. And we will do it only when it's not pressed already, it's not running already. M2. Okay, new network, and we do the same for backwards command. So 2 coils, rising edge from M1. If not M3, then set M3. What we might do is also to create a condition that if the other command is not already executed, we will not allow to run the other command. So here also we have to given location. Okay, so here is where we set our run commands forward and backwards. So now we have to actually execute our high-speed control function. So to rotate our stepper motor, we can use pulse output or pulse output with accelerate and decelerate. We'll use the other one with decelerate, and we will use 32 bits instruction. Okay, to be able to do this part, we must jump back to hardware configuration, and for our first output we will declare that we want to run pulse and direction. This will be our Y0 and Y1. So now here in PLSX we declare which output we use, so in our case it's output 0. Acceleration deceleration time in milliseconds will give 200. Okay. Pulse number of pulses. Our stepper motor controller is set to 400 pulses per revolution, and we want to make 10 revolutions, so this will be 4000 pulses and frequency 10 kilo, which is 10,000. Alright, so this will be our control to run a frequency drive forward. So conditions would be whenever we have our M2 activated, M2. So when there is a command to run forward, we'll execute this one. We also must reset this M2 command whenever whenever it's already finished. So we will reset M2 here, and so we will reset it when the command is executed and we get system bit called I think it's called high speed output 1, high speed output 1, pulse output complete, so that's SM100. So whenever we had this instruction active and the pulses is done, then we will, that should be actually a reset command. Then we reset M2. And we will do the same for backwards command. So M3, this we will change to 101. The only difference that when we run backwards, we must give negative number of output pulses. So we will do 10 resolutions backwards, the same time and the same frequency. Yes, this way. Change to 101. And we reset M3. Okay. Let's try to connect to our T-series CPU. Okay. And we load the program. We must save it first. We have some warning. This is because we didn't put any tag here. And also, okay, here we don't need actually any condition. Yes. start monitoring. So our program is ready. We read table from PLC 1. So we'll try to press the button and see if it's rotating. So first we press X0, rotates forward, X1 rotates backwards, forward, backwards. So this is how to program a stepper motor using Haiwell PLC. Thank you very much and see you in next video.